wonderful day. We, Group 1, will provide the SPSS results and interpretations, also the answers of our group to the questions provided.
Pedro is trying to check whether gratitude and work stress are related. His hypothesis is that a person who is grateful tends to experience work stress less. He measured both variables by giving a gratitude and work stress questionnaire. Both questionnaires use a 4-point Likert scale. They gave their scale to 9 employees. After, they averaged the scores of the respondents and obtained the following data. He measured both constructs variable using the scale below. 4 for high, 3 for relatively high, 2 for relatively low, and 1 for low. The data he got from his measurements can be seen below. Now that Pedro got his data, he wants to predict an employee's work stress if they have an average gratitude score of 3. What is the predicted work stress level? For gratitude, 1.25, 3.14, 4, 1.16, 1.18, 2.78, 3.65, 1.98, and 3.33. And for work stress, 3.22, 1.23, 1.12, 3.56, 3.45, 3, 2.30, 4, and 2.10.
We have provided two variables in which we labeled both of them as gratitude and work stress, in which we have 9 employees in total. Each employee would have a corresponding number of gratitude with their work stress, which concludes that each person would have a score in each variable. In simple regression, we have scores on one variable x to predict scores on our y variable.
In a given data, gratitude would be under x-axis since it is an explanatory variable, which is the independent variable. That would affect the measurement on y-axis would be the work stress since this is the criterion variable, also known as the dependent variable, since the gratitude will be the one to predict the work stress, in which this is evident by the example given, wherein Pedro used a questionnaire where it could determine the specific variable.
So to run regression in SPSS, you would want to click on Analyze, then click on Regression. Then press on Linear, where we would analyze the linear relationship between the two variables. The linear regression dialog box would open, where we could see the dependent and independent variable. Gratitude would go to the independent variable, and work stress would go to the dependent variable. Finally, there are 4 tables in our output, which we are about to discuss.
Notice how the dependent variable is the work stress, which indicates that the data entered is accurate. Moving on to our model summary table, but first, we are to explain the R in the model summary table, in which this depicts that multiple correlation coefficient in simple regression, where we only have one independent variable or x. This simply means that it's just really equal to the Pearson correlation, where in fact 0.824 is the correlation between gratitude and work stress.
Next, in our model summary table, in which there are two variables that we are to tackle, that is R and R squared. And as mentioned before, that R has multiple correlation coefficient in simple regression, where we only have one independent variable or x. This simply means that it's just really equal to the Pearson correlation, where it is simply the correlation between gratitude and work stress. Next, R squared is equal to 0.68 in the given data. And to give a brief explanation, R squared is the amount of variance in the dependent variable, which is the work stress, that is accounted for or explained by independent variable, which is the gratitude.
A way for us to interpret this is that we would take this into a percentage where 0.68 and convert it to a percentage by multiplying it to 100, which would become 68%, which means that gratitude explains 68% of the variance in work stress, or in layman's terms, we can predict almost 68% of this data, in which we cannot account for or explain nor predict about 32% of the variance in gratitude. So, that 32% we don't have control over that percentage But the other 68% we can completely explain by knowing gratitude alone.
Moving on to our next table, which is the ANOVA, this depicts that gratitude is a significant predictor of work stress or not, whether it is statistically significant and does it depict work stress beyond chance alone. In simple regression, we can use ANOVA or coefficients. Notice how we both have a value of 0.006, so these two p-values are identical, both under ANOVA and under coefficient. So the decision rule for assessing if the test is significant for alpha equals 0.006.
If P is greater than or equal to 0.05, the test is significant. Gratitude is a significant predictor of work stress. And if P is greater than 0.05, the test is not significant. Gratitude is not a significant predictor of work stress. So as you can see, the p-value of our data is 0.006, which indicates that the test is significant, where gratitude is significant predictor for work stress.
So next is that we would provide the written results in APA format in which it is provided in both tables. This would determine whether gratitude is a significant predictor of work stress or not. Using the ANOVA table, we can conclude that gratitude is a significant predictor of work stress. In here, we have an F statistics, which has a value of the degree of freedom, which are 1 and 7, which can be found in the degree of freedom column. 1 for regression, then 7 for residual. Then we have an F of 14.85, which are rounded off to two decimal places. Then a p-value of 0.006 and our multiple correlation coefficient R squared, which is 0.68.
Then we would now proceed to the APA format using the coefficients table. We would want to highlight on the three values that are highlighted on the screen. That is the beta coefficient, which is equal to negative 0.82. A t-value of 7 equals to negative 3.85. We got the value of 7 by n minus 2, which is 9 minus 2, and our p equals to 0.006. Then our r squared is 0.68. Then we are to determine the relationship in the t and the f value, where f is equal to 14.848 and we found our t value of 3.853. When we square that, we would get the same value.
Okay, next is we would want to compute for the regression equation, which is y for the predicted work stress value is equal to 4.55, which is the constant in column B in the coefficients table. Then we have negative 0.756, which is under gratitude. Then we have work stress in parentheses. This is an equation that would help us predict the employee's work stress if they have an average score of 3. So we would want to go ahead and use this value in a regression equation value, in which we would have y for predicted work stress value is equal to 4.553 plus negative 0.756 times 3, which is equal to 2.285. And if we were to base this on the arbitrary scale, we would conclude that the employee's predicted work stress level, if he or she were to have an average score of 3, would be relatively low. And that concludes our presentation for today. Thank you for listening.